Okay, because arrays tend to be an item that confuses new programming students, I'll just spend some extra time, and I'm just going to narrate the PowerPoint from the book, and then open and do a programming exercise. Real important to understand the array basics. This 8.1 from the chapter is the most important thing. The rest of these are less important. 8.3 is going to be useful to you for a lot of your program exercises. If you understand the concepts from 8.1, that shouldn't be too bad. Same thing with 8.2. So 8.1, 2, and 3 are the important things. 4, 5, and 6 are kind of some advanced things. You know, if you plan on going ahead with the programming, try to understand these as we can, but they'll be reviewed in the intermediate courses. And so what is this thing in the array? It's just a way to store groups of items that have the same data type and store them together in memory. You've had programming before where you've had to store a lot of similar items, a lot of similar variables, like employee 1, employee 2. It's more efficient when you just have one variable with one name and store all that in there. When you see these square brackets is how you identify when an array is involved. This is a super important graph from the textbook. These 2 lines of pseudocode create something that looks like it's in memory. And you should have something like this on a blank piece of paper next to you when you're programming. The only other thing I advise is add the word numbers on the left side of this drawing here, and label it like this: numbers, and then put a 0 underneath the first box, 1, 2, 3, 4, and 4 underneath the next boxes. Size being used to declare how many of these boxes you were going to need. Size is a constant. It's just a regular number variable, and that tells the computer how many of these boxes we want. The exact way that you create this structure in memory is going to be different in every programming language you use, including Raptor and Python. This concept of what an array is and how there's elements in the array has a size, that's going to be the same for every programming language. And this is how working with arrays, this is how to do it. Anywhere that you had used a regular name of a variable, you can use an array name with a subscript or index number inside of these square brackets. A lot of new terminology this chapter. Several chapters had new terminology, but this especially. Array name is here. This is called an index or subscript, and it goes inside the square brackets, and then you can use it with an assignment operator. This is pseudocode, remember. You're not going to use the word set in Python or in Raptor. This is just what's going on. Setting 20 into number 0. Going back here, that was putting a 20 in this first box all the left. That's what that code would do. You should do that on your piece of paper when you're with arrays. This is putting a 20 in that first box, a 30 in the next box. The box, this is the L number, this is the subscript number, 0, and this is the array name. This array is numbers, these are the or the subscript, or the int numbers, all really the same concept. So this is another array. Looking at this is an array called hours, and you use this exact thing, hours 0 or sub 0. You would use that anywhere you've used a variable before, and it's going to refer to value 40. Initialize is just a fancy word putting values into a variable as soon as you create it. All right, so this is declaring a variable declaring a variable that's an array, declaring an array called days. This means that it should have 7 elements, it should have 7 boxes. And this is putting each of these values into those boxes. Again, this is pseudocode. The exact way you do the different programming language is going to be different. So you should understand how this works and what's going on. There's a long string of boxes called days. There's 7 individual boxes within that. And this Sunday in the first box, Monday in the next one, Tuesday in the next one, starting with the 0 as the subscript. This is just something that's not real important. If there's unfilled elements, some programming languages put a 0 into them, some have it null or undefined. Don't really worry about it. The for each loop is a very handy loop for going through all of the elements in an array. The syntax is a little bit different in Python, and there's not really the way to do it in Raptor, but it is very handy, and I'll show you how to do it in Raptor later, or in Python. It's just a way where it's going to iterate through each element in the array. So here would be an example of that. A called size, and it's good to have constant to use with your arrays because the size is going to be, and you're going to use the size in a lot of different places. And if you have a constant for size, then you can just change this constant one place, and your array is going to still work with all those other things you do with it later. So we're creating a variable called numbers, an array, and it has 5 boxes. It has 5 places to hold information. And this is initializing it right away by putting 5, 15, 20, 20, and 25 in those boxes. You have to be able to draw this. You have to understand enough to draw what this looks like on your piece of paper. Now we're declaring another variable, another box by itself called num. And with pseudocode, again, just pseudocode, we're saying for each num in numbers, what's going to happen here is this num variable is going to take on first 5 the first time it goes through the loop, then 10 the next time it goes through the loop, then 15, then 20, then 25. So basically it's like a for loop, but you don't have to increment anything, you don't have to check anything. Num is going to be the first element the first time it goes through the loop. It's going to be this element the second time it goes through the loop. It's just going to keep on taking on values inside the array. It's just some pseudocode for the logic involved with the sequentially search an array. Sequential search algorithm. Right? An algorithm is just steps you take to solve a problem. The problem here, we're searching for something. We're looking for something. Sequential means that we're looking for it. We're going to look at one thing at a time. Right? Again, you need to have a piece of paper and you need to draw what that array looks like in order to understand how this code works. You're going to start at the left side with index 0. That means all the way on the left of the array. And we're going to keep on looking until we find it. It makes sense to keep on looking after you found something. We're going to keep track of whether we found it or not with this Boolean variable called found. We're going to assume we haven't found anything. As long as we haven't found it and we have gone through the entire array. That's what index is less than or equal to size minus 1 means. We're going to keep on looking at the array, at the individual location, the individual box in the array to see if it's equal to what we're searching for. If it is, we're assigning true to that Boolean variable found. Otherwise, it's going to change index to index plus 1, which is going to have the effect of looking at the next spot when we use it in the if statement. Getting the totals and averages in an array. Again, this is just pseudocode. We have an array called scores with a size of 5. I'm going to switch over to the e-board to draw what this looks like. Try to draw it on your own paper. Pause this if you need to, and draw what you think that code looks like. And because the size was 5, that meant to make 5 boxes. And underneath those boxes, you start with a 0 for programming languages. Then into the boxes are being assigned these values, 2.5, 8.3, 6.5. So I'll just put those numbers in here. You have to be able to create this based on a line of code. This was line 5. Line 5 creates this. You have to be able to draw this on a piece of paper to help you immensely when you're writing your programs and when you to understand programs that other people have written. All right, these are all scores. They're all related pieces of information. They're all the same data type, so we're going to use them in an array. It's a good time to use an array because you'll see we build some very useful things. We could have kept these in score 1, score 2, score 3, 4, and score 5, but by keeping them in an array, we're going to be able to process them much faster and do all sorts of things with them, such as in the total and the average. All right, so that was from line 5. We'll create that thing that I drew on the board. Now, here, total 0, that's creating another box by itself of just total and putting 0. This is creating another box called average without putting anything in it. Creating another box called index, not putting anything into it. Now, for index gets 0 to size minus 1. So index is going to start at 0 and go up to 4. This is a for loop. We're setting total to total plus numbers index. The index is going to start out at 0, and total is going to get total plus scores index. So 2.5 is going to end up in total. Then index gets incremented. That's how for loops work. If you don't remember how for loops work, you might need to review that after. The for loop is going to process the inside the loop, and then it's going to go back. We're going to do scores 1, which is going to mean to look at the 8 and 3. And it's going to do total get total plus scores 1. So it goes to 10.8 in total. And then the for loop happens again, this time at 2. And total gets now 16.9 or whatever. That's lines 17, 18, and 19 are doing. Remember, in Python, you don't need the word end for. It figures out where your for is done whenever you stop indenting. But other than that, it's going to be pretty similar. Right, index is going to keep on inking from 0 to 4. So numbers index is just going to mean that box, and then the next box, and the next box. When we get done with the whole loop, we have the total. We can just divide by size because 5 scores. Right? 2.3, 0.3, 6.5, 4.0, and 5.2. Those are 5 different scores. So the total divided by the size is going to give you the average. To find the highest and lowest value, this is the way you would do it. This is the way you do about it. You create a variable to hold the highest. You assign the value at 0 to highest. Then you loop to step through the rest of the elements, checking to see if they're larger than highest. If it is larger than highest, then you assign value to highest. This slide isn't, if you need to be able to understand what's going on here to do your programming challenges. And it's not real hard, you just have to visualize it and stop, think of it, look at a drawing, and then do it. Copying the contents of an array, not real important if you don't understand at this point. If you understand it, great. If not, don't worry about it too much. There's plenty of exercises you can do that don't involve this. The moral story is that you just can't copy one array to another to loop through each element in the array and get over it. But don't worry about it. Parallel arrays just means that there's 2 different arrays. They could be different data types, but the item of information at the corresponding element numbers relate to each other. So here you could have a name of a person and an address of a person in 2 different arrays, but at subscript 0 of names and at script 0 of addresses, that information is related to the same person. That's all a parallel array means. 2-dimensional array, just think of a table. Think of like an Excel spreadsheet. But before, we were figuring out which box we were talking about in an array. We just had to use one number in those square brackets. With a two-dimensional array, we have to have the row and then the column bracket, like this. Three-dimensional arrays, you do have to know this and understand it thoroughly for this course. We're just doing some groundwork for you so that when you see it again in an intermediate course, you'll have a little bit of pre-knowledge of it. Three-dimensional array, you just about it as having multiple pages of tables. So don't worry about it too much. All right, I'm going to stop this archive for now, and then I'm going to come back and do another one for walking through the program challenge.